Eris is gone, done? Alright, and then Luca's coming from Chapel Land, and then Eric is gone, done?
Yeah.
Done. So hopefully Jesse comes and hopefully Luca comes. Yeah, because remember we skipped 9-4, so we went from 9-3, and then we finished 9-5 on Friday. At least mostly. Did we finish? Oh, there was one type of like homework help that I was going to see if you guys were able to figure out, but it was all of our binomial theorem, jumping. Let's check. Okay, guys. Gotta focus. Got a test coming. Let's check 9-3. Let's go look at the homework help example that we didn't get to do on Friday, and let's see if you guys understand how to do it now with the homework stuff that you did over the weekend, and then let's go check homework. Just in case this is the question, I'd rather cover it in our notes first. Is that okay?
Okay.
Alright, so homework spiral is out 9-3, then keep your homework spiral, but grab your notes open to 9-5. Let's do this one last example, then we'll go check 9-5, and then we can start 9-6. P.S. Happy Monday.
Happy Monday.
You guys alive?
Barely breathing.
How many guys are tired from? Oh, it was too light. If it was heavy, it would have been fine.
Oh, I totally thought he was throwing it. I was like, okay.
Eileen, there's one notebook to grade. Go ahead and give it full credit.
Out of 30?
Yeah. And then Karen, Eileen will need the grade book in a second. Alright, kiddos, here we go. 9-3, number 8. Geometric, yes. R is equal to negative 2/3. Brandon, shh, Nolani, focus. Number 8, yes, it is geometric and R equals negative 2/3. Number 14. You guys can see the first 5 terms. Plug it in. Actually, no, not even plug it in. Use the pattern. Start at 8 and then times 2, times 2, times 2, times 2. Ta-da! Number 24. Use the pattern. It was written, what's the word for this type of defining of a sequence? Recursive, good. Recursively defined has to do with programming. Start at 81 and the pattern says times 1/3, times 1/3, times 1/3, times 1/3. What's another way of thinking of 1/3 that our mind is probably faster at? Instead of thinking times 1/3, we can think divide by 3, divide by 3. It's just a little bit faster. R is equal to 1/3 as shown. And then you would have needed to take those clues, the first term and 1/3 as your ratio, and plug into your A sub n formula. Now, guys, look real quick. Is this 81 times 1/3 to the n minus 1, is that correct? Yes, that's a strict plug and chug. Does anybody have a question as to how they got this one? No one has that question? Who wrote down this answer, 243 times 1/3 to the n for number 24? Okay, then how does no one have a question as to how it's right? How many guys wrote down 81 times 1/3 to the n minus 1? Okay, so the rest of us didn't do homework at all over the weekend? Weren't you just plugging and chugging, guys? You have A1 from your recursive formula, you have times 1/3. That gets plugged into the A1 spot, 1/3 gets plugged into the R spot. That is the formula from our notes that we're supposed to be memorizing? Yeah. Real quick, how did they get 243? What's the difference? What's missing in the second one that's not in the first one? The minus 1. With exponents, what does the minus 1 indicate? Not inverse. If it was just negative 1, maybe. Huh? Not positive. 1 below. I like that notation a little bit better. So the negative 1 power means over 1/3, right? So couldn't we write this the same as 81 times 1/3 to the n? Question. What do we do once there's creating homework spirals 9-3 right now? What do we do with exponent rules when we have like bases and there's division? Don't we subtract? So this is a rewriting, this is an expanding of what this notation is. The notation says 1/3 to the n divided by 1/3 to the 1. The notation says n minus 1, which is true. Here's another way of writing it. Now, can I simplify everything without an n? And the answer is yes. How do I simplify everything without an n? Multiply the top by 3 and multiply the bottom by 3. Multiply the top by 3. Guess what 3 times 81 is? And 3 times 1/3, they cancel out. 3 times 1/3, they cancel out, so that bottom is gone. 3 times 81, 243. Anyway, long story short, how is this practically applicable to you guys? You should have been able to plug into the formula for this first version, right? The question is, what if a multiple choice answer has the second version? Does that make sense?
Yeah.
Because you might have the right answer and not realize that you can make it match. That's why I wanted to make sure that you guys saw that. Plus, simplifying those exponents is a common last step in simplifying answers. Okay, let's go ahead and clear that out. It is in the video for my kiddos that came in if you need to check it out. 24 has kind of a weird answer in the sense of they did just plug it in the formula and then they simplified. Number, where are we at? 40? It's like right that part of the board that I can't see. There we go. Number 40. A1, A2, A3 is what they gave you. From that information, you could have divided A2 over A1 or the ratio of A3 over A2. Either way, you get the common ratio of 12. Then, guys, isn't that the formula that you're supposed to be memorizing / using? Right? Plug in your first term, got it. Plug in your common ratio that you found, got it. And then you have your formula to find the 7th term. Plug in 7, 7 minus 1 is 6. Ooh, that's a big term, 8,957,952. Number 48 matches letter C. Because it's going to bounce back and forth between positive and negative. And then number 62, I think, is our final for, oh, nope, we have another one. Sorry, I apologize. 62, final answer is 12.5, which is a fraction, 12 and a half. Would that be 25th, 25 halves? If you were to simplify, and you guys can hopefully see your S sub n formula, your S sub 41 formula right here. It was a little weird because you had an extra 5 because of n equals 0. If you're wondering how they did that, it was a little weird because you had an extra plus 5 when you plugged in chunked. Because when you plug in 0, you have a 5, and then you have 5 times 3/5 and 5 times another 3/5. So there were a few different ways of setting this up. They just went ahead and said, you know, that 5, I'm just going to leave them off to the side, leave them off to the side, leave them off to the side, and add them at the end. A couple different ways of doing that. And then I think now we're at our last one, number 70. Oh, man, there were a lot of evens this time. A1 is 15, R is equal to negative 1/5. They plugged and chugged. They used trial and error. Did anybody get stuck on this one? Why did they use trial and error? What was wrong with ln? Wait, why am I talking about ln? What's the only way to solve this expression, kiddos? Yeah, to take down the exponent. The only way to take down the exponent, you can divide the 15 and you can get there. But to get this exponent down, whether you do it here or whether you do it in the next step, is to take ln of both sides, right? But if we were to take ln of both sides, which we talked about in class on Friday, what's the problem of taking ln of a negative number? It doesn't exist. You're going to get an error, right? ln's of negatives don't even work. So why are they saying by trial and error? They're saying, well, I guess if ln doesn't work, we just say, hey, what if n is 1 or 2 or 3 or 4, and it'll finally work at 6? Is there any other way to go about it? Kinda. You could just play with what if it was a positive number, but most of you are like, I don't like the what if it was a positive number. I kinda might get you a little frustrated. So you could play on the fact like, okay, I can't do ln of the negative number, but what if I just take ln of the positive number and pretend both sides, in a sense, multiply both sides by a negative? You can multiply by a negative, you'll have an even power. Multiply by a negative, you'll have a positive. So there is kind of a way to solve it, but you would have to kind of go outside the problem and say, I can't do ln's with negatives, so let me pretend it's a positive, and then I can work with it that way. But you can also just say, what if n is 1 or 2 or 3, and plug and chug. And then they wrote it all nice and pretty in sigma notation. That was part of the question as well. And number 78. Final answer is 27, the infinite sum. Why does the infinite sum exist? Why is this a good thing? It's smaller than 1. Good. Any ratio smaller than positive 1, bigger than negative 1? The infinite sum does exist. I plug and chug it and I get 27. Okay, so here's the scary thing. 9-5 is the homework due today. And when I started asking questions about that one in particular, the response was very, very, very minimal. If some of you guys are 2 homeworks behind going into this week with a test on Friday, is that a good thing?
Nope.
So we need to buckle down. We need to say, hey, Honors Pre-Cal is worth my attention. And if you didn't give it this weekend, you're going to give it by Friday. Or else our grade's going to start tanking and we still have a final coming that's not an easy one.
Wait, is that gonna be like a whole year or just this semester?
Just this semester, but believe me, it's enough. It's enough to be challenging. Okay?
We'll have stuff from the last semester too.
I mean, there's some
To
stuff that shows
accomplish,
up,
yeah.
but it's not particular to last semester. It's particular to this semester. So kiddos, I love you guys, and you're usually super enthusiastic. Maybe it's just a bad Monday, but if you didn't, I don't know. When you're behind going into a weekend, you try to catch up. So I'm not sure what's going on. If you need to talk to me, but we have a test this Friday. And now is not the time to be slacking off.
Which chapter are we going up to in the CD thing?
Oh, all the way to the end, but we're skipping chapter 11, I think?
What is the last one?
12.
Oh, we're good.
So we have at least 2 chapters. We will be good if I don't lose some of you guys along the way. No man left behind. I don't want to leave anyone behind. Not at this point.
We do this together, Steve.
I hope so. I hope so. To that end, we are going to check section 9.5, but we are going to go ahead and get back into our notes, like I said, with that example. We're going to do an example, but let's pause for just 1 second. Some of you guys don't want to be honest with me in the sense of how you're actually doing in this class. In the sense of my keeping you accountable. But let's see if maybe you guys can put a little bit of care and concern in the people in your groups. Right now, I'm pretty much going to start ignoring the conversation for the next 2 minutes. I want you guys to check in on each other, check how they're doing. First of all, just life. Check in real quick on life. How's it going? Check on weekend, because maybe it was stressful and long. And check on where they are in homework. Okay, you're checking in on each other. This isn't like a, booyah, I'm on top of things and you're not. This is we care about each other, and from what I just said, some of us are struggling a little bit. Now, if we start laughing about it and making fun of how behind we are, is that going to help anything?
No.
We got to be serious. So Brandon, go ahead, and you're facing up because your group, I think, is Sean and Nicole. I want us to quickly check in, see how each other is doing, see where we are. And then we're going to ask each other reasonable goals to have done by tomorrow, and we're going to check in. Okay? The Bible says, as iron sharpens iron, so should one. Is it a friend? So can a friend sharpen another? Basically something, that's my rough paraphrase. It's from Proverbs. As iron sharpens iron. Sometimes we need accountability, and some of us need more accountability than the homework spider will do the day of the test that we don't necessarily put a lot of good work into. So let's take 2 minutes, check in on each other, see how they're doing with life first, then with math, and then ask a reasonable goal for everybody to have for tomorrow. Ready, set, and go. How many are you able to finish?
It took me like 2 months to find the actual slipper.
You don't have super long, but let's start caring about people.
Oh my gosh, every guy's a great day. We gotta do
Yeah. In her favorite movie, Cinderella, so I put the beginning music, but Dream is a wish and harder. Then I said in my dreams to put a prom with you. If the shoe fits, will you be my princess for prom?
Alright, 1 more minute. Make sure you get that reasonable goal thing for tomorrow.
And he was at Disneyland. I never went to Disneyland with her.
Wait, you went to Disney?
Yeah.
Okay, pause. You should have already moved on to math by now, and then you should be already figuring out everybody's reasonable goal for catching up for tomorrow. So sleep the phone if you don't want me to take it. It was on the Snapchats.
Okay, that's so cute. Oh my god.
All right, 30 more seconds. You guys check up on how people are in math?
Yeah.
All right, pause. Which of you guys have stated your reasonable goal for math for tomorrow? Okay, I gave you like 3 minutes instead of 2, so pause. Let's take 1 more minute. You were supposed to end with what's reasonable goal for math for tomorrow. You're keeping each other accountable. If you're not done with 9-5, maybe that's your reasonable goal. I'm gonna have 9-5 done, have notes up to date if you've been absent, have watched videos, I don't know. Something that you're gonna catch up on tonight in this class. Ready, set, go. Something measurable, something practical.
I need to finish the last round on 9-3.
Come in and ask me a question on something particular after school today.
You know that you have to do.
It's hard when you have to find your stuff yourself. Like round 1, you have the sequence and then you're
Maybe making a formula card, start studying them.
we have a
Formula study card. I said to study them.
You didn't have to write like any instructions.
I didn't mean, I apologize. I meant like a formula study sheet. All right, let's come on back.
I actually need to make one. That's important for this test.
Now, as a class, since you guys were able to check in with each other and you know reasonably where each other are as far as what they're up to, what they're caught up to, what they're behind on, etc., you have reasonable, measurable goals to check in on each other tomorrow with, because I can't personally keep each of you accountable with where you are since you're not turning in things until the day of the test, right? I figured it'd be better for you guys to face-to-face contact kiddos that you've been sitting around all year, checking in on, showing that you care about life number 1, and you can kind of check in on them that way and be encouraging to each other that way, but also in math as well. But also to give you sympathy if they are behind, maybe there's a reason they're behind, and to check in on them with that as well. But to make a measurable goal to say you can't just drop your responsibilities when life gets crazy, but sometimes you have to kind of prioritize and think about it. Having talked to each other, is it reasonable, practical, helpful for the entire class to check 9-5 today as a collective group? Answer yes or no. No. Okay. So we're not going to check 9-5 today. We're going to check it tomorrow. Do you guys see what I did there? We're a class, right? We're one big class. Yeah, we can think of it that way in the sense of we're trying to get to the end as Honors Pre-Cal together, not leaving anyone behind. But can we reasonably get to the finish line well if we just say, oh, it doesn't matter, let's just slack off? No. But can we be sympathetic to those that have gotten behind and try to encourage them to catch back up and offer help and maybe exchange numbers and be able to, especially those who have certain productions coming up soon or different performances that they've had to do or track meets all day Saturday that they had to go to or missions, yard sales they were trying to help out with? Okay? Totally fine to be texting each other and encouraging each other and offering to help each other along the way, yeah? Okay. We're not going to check 9-5, so let's finish off 9-5 notes. Sound good? Let's do 9-5 this example. We're going to start 9-6. I did just basically move the test to Friday, so we have a little day of grace. But 9-6, 9-7 is probability, which some of you are like, psh, got it, and some of you are like, oh, I hate that. Especially if you've been studying or trying to take the SAT, does probability ever come up? So it's practical, it's useful, we don't want to waste our time and only like barely touch on it, but we do need to get to this test because there is a very important couple chapters that are still coming. All right, quick questions about logistics, life, etc. Jessie?
So Thursday's just
Thursday is just a review day, and I figured that would help out with band and the Biola things. Okay. Thursday's a review day, Friday's our test. Sound good?
Yeah.
Okay, so we can take like a day and a half on 9-6, day and a half on 9-7, which we can spread those out kind of well as well. All right, kids. Real quick. Since we weren't ready to grade 9-5, can I expect you all to have a mastery on 9-5 right now? Yeah. All of you? Come on, be realistic. What happened? How can you have mastered 9.5 if you haven't personally, without me, practiced it? Has anyone ever seen me do a problem, thought it was easy, and then go to homework and say, oh wait? Raise a hand, raise a hand, raise a hand. Okay. So you can't just watch me in class and be like, psh, mastered it, if you haven't actually worked with it. So let's quickly go back to 9.5 because some of you haven't even thought about it since class on Friday. For whatever reason, I'm not publicly shaming you. You have your reasons. Some of them are good, some of them are bad, some of them are in between. Let's quickly think about 9.5 for just a moment. What were we working with? Raise a hand. Someone give me something from 9.5. Sean.
Binomials with varying numbers and varying degrees.
Good. I'm going to change it to varying terms. Varying terms and varying degrees that it's being raised to. Cassette, give me something else. Pascal's triangle. Connect that for me, Cassette. What does Pascal's triangle, those numbers, what does it represent or do or find?
It's for expanding. I know that you can use it to expand binomials. That's about all I can
Cool.
remember.
Coefficients in front.
Yeah.
Coefficients in front when we expand. Brandon, give me something else.
CNR.
Yeah, NCR. This little formula down here. NCR is a way of jumping to a particular place in Pascal's triangle. Now, you guys remember that I said on Friday, I did this extra credit assignment in high school for Pascal's triangle? You do, maybe you don't. I found it this weekend when I was playing around with stuff. I knew it was in here somewhere.
Jeez.
Wow.
That's
It wasn't, doesn't look
That's
very
our
nice
math
and even,
teacher.
because I'm like, oh, this will be easy, and I was like, oh, crud, numbers get big. I ended up at, how should I be able to tell what power I ended up at? Do you remember?
The
by
second.
the number
The
of
second
rows.
number, because right, we have
Plus one.
ones all here, ones all there, and then this main diagonal tells me what power I'm raising to. I got up to the 50th power,
Oh my goodness.
and it got kind of messy at the end, and that's why I stopped, because I
What's
didn't
the
want to attach another
bottom?
paper.
What's the number in the middle and on the bottom?
In the middle?
Yeah,
You can't tell the middle, because it kind of got off, because the numbers got really big, really fast. But
in the bottom row.
somewhere towards the middle, oh, there we go. 86955197046.
Oh my goodness.
There's the symmetry because I can see the 7-9 on that side, 7-9
How long
on
did
that
it
side.
take you to do that?
I don't even remember. I was a nerd. Anyway, look how old I am. The tape is so sad. Anyway, so,
You should frame that.
well, the lack of symmetry really bugs me on it, so. But anyway, could you, if I was to say something like x plus y to the 50th power, could you make a Pascal's triangle and get to all the different terms in the 50th power expansion?
As disgusting as it
could.
is.
Do you want to?
No, you don't.
So what do we have as a backup?
That formula.
NCR. But we need to be able to jump to a particular spot so we don't have to do this. And yes, the numbers are really kind of tiny and small. And if someone wants to be super cool, they can double check if I actually got it right, because I never really have, because I didn't really care that much. But anyway, if you want to pass it, you can. Yes, it's exciting. But coming back.
Oh my goodness.
You guys are behind on what you're supposed to do.
Savage thing.
Maybe.
It's like
Let me
one
think
number.
about it tonight. Ask me again tomorrow.
Sad. That would be so easy.
But now we have computers and stuff. You guys just type it up. Back then it was. No, I think it had to be
The fact that
handwritten.
you got did you use a ruler or did you just write across? I got yours. Because it
I
was
think
like
I used it. No.
It'd be
I
even more
didn't use
impressive
a
if you
ruler.
did not use a calculator.
Oh, psh, I used a calculator. Okay. So I used a calculator not to do the NCR formula. That's why I could have actually gotten off somewhere. But you guys see how the numbers randomly got huge and then it's hard to keep the symmetry? It's so sad.
She can write small.
Anyway.
by the way.
Yeah, I
Hey, at
can.
least you attempted the symmetry.
When I want to. So the NCR helps us jump. So then with that, we talked about how to find NCR, we talked about Pascal's and all that jazz, all that jazz, all that jazz. And then we started expanding. Now kiddos, if it says expand, how much of the polynomial does it want? All of it. It wants the whole expansion. Like if you were to multiply it to the 5th power, like FOIL and then multiply those two with polynomial multiplication. That's what it wants. But if I give you something like a certain characteristic of a certain term, do you have to expand the whole thing? No. Could you? Yes. If you don't know any other way to do it, could you do the entire expansion and then find the right one? Yes. But what did we practice in the next example? How to jump there. How to jump there. Can you guys remind me real fast? What goes, let me try to highlight, what goes in this top spot of NCR? Because that's what this little parenthesis thing means, right?
Isn't it?
N goes on top. What goes on bottom?
R.
R. What is R the same thing as over here? The degree or the power? Which term is being raised to? The second. Whatever's there. Could be a Y term, could be a B term, could be a number. But R is the same thing as what B is being raised to. And then how do I figure out what A or the first term is being raised to? How could we have figured out 2?
N minus R.
N minus R. The powers always add up to 9. And then you have to go ahead and plug and chug and solve, and then we got our final term. Without having to do Pascal's triangle to the 9th row, well, technically the 10th row, to the row with a 9 as the second number. And without having to use the entire binomial theorem to go all the way across and then find the right term. So this is the example we didn't get to do on Friday. Okay? Let's see if we can jump there, even though Pascal's triangle, sure it'd be great to go to the 10th row and go ahead and see what the expansion is. But let me erase all this stuff so you guys can see clearly. Go ahead and get the information down if you didn't get to on Friday. We're trying to figure out, can we jump to the term with the binomial theorem? Can we jump to the term given what they have asked us for? A, x to the 8th, and y to the 2nd.
I think so.
A, x to the 8th, and y to the 2nd. As we start, hopefully you know right away. I'm going to go ahead and put it in. Let's see. It's something light that I can do. Let's do like a light gray. Okay. I'm going to go ahead and say we need something here, right? We need something here, right? We need something here, maybe a short something, maybe a long something. I'll just say something. How did I get x? Why am I putting that there?
Because you took
Good, it's the first term. Why am I putting negative 2y?
you have to take the whole term.
Yeah, do you think about adding a negative? We need that negative to go with that 2y. And something here. Do you guys see what we're trying to fill in? Okay. So, what is something, I'm going to go ahead and make that box a little bit nicer. I know I'm a little bit OCD right now. Okay, question. What is something that we can fill in based on this term that they have given us? Is anyone else annoyed by that? Hold on. Oh, now it's darker color. We should sue.
Bill Gates, why?
Almost. There's one more little white spot, but I'm not going to go back and fix it. Okay, so is there something based on this term that they have given us that we can fill in?
We could do the 8 and 2.
Where can we put the 8?
Put the 8 above the x, right?
Okay. We know x is going to be to the 8th. That's good. What else? Okay. It's like, oh, this is easy cheesy until we're like, aw, stink.
Isn't it just 10 and then
Why 10?
10,
Because
2,
it takes power.
Because 10 comes from the n, which is the power.
and
Good.
then 2.
And then 2,
And it
because
is
r is the
8.
same as the second exponent.
And 8 plus 2 is 10.
Does that make sense? It's not crazy hard as long as we get down the pattern. Brandon.
Wait, how did you put 2?
Well, the 2 is because, as we go back to our, real quick, I showed it in this one, how the power that the b term is raised to is the same as the second number in NCR. But if you want to see in the formula, we'd have to go back to our original binomial theorem. And in our binomial theorem, there we go. You can see right here, y is raised to the r, and r is the second number in NCR. So if we know what y is being raised to, then we can know the second number to put into our combination. Or if we know the second number to put into our combination, then we can say what y is raised to. And x is whatever is left over from n. So let me go back to the example real fast that we're working on, which is this guy. Oops, I'm zoomed in. There we go. And as soon as we could see in, let me get a different highlighter out real fast, as soon as we could see in the term that y is squared, we know that whatever is in this b squared term, whatever is in this b squared term is going to be the exact same number as what should go into my r spot. Does that kind of make sense?
Yeah.
But it's one of those, if you don't get the pattern down, it could be pretty rough. Another way of thinking about it, if this helps in the logical sense, without just like all the patterns and the arrows and all that craziness, is that we could say, in this NCR notation, it means that out of 10, or for the 10th power, raising it to the 10th power, that 2 says that we are 2 spots from the end, which is kind of weird to think about. Or sorry, 2 spots from the beginning. That's how I should put that. We are 2 spots from the beginning. I think I have that on, which page? Here we go. Looking at the second number, do you see how the 0 is the first spot? 0 is the first spot, 0 is the first spot. 1 is the second spot, second spot, second spot. 2 is the third spot, third spot. So we could think about those bottom numbers as telling us as what position we're supposed to be in sense of the terms. That might help just a little bit. And so we can think of, okay, we need to be, for this example, we need to be 3 spots in. 3 spots in means, okay, you've had the x to the 10th term first, whatever that is. There's like blah, blah, blah before and after, plus. Then you have the x to the 9th spot, blah, 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 coefficient, y's, etc. after. And then you have the x to the 8th term. So that 2 kind of denotes that we're in the 3rd term over, which means this one y was to the 0, this one y was to the 1, this one y was to the 2. There's a few different ways of linking all that stuff together. Anyway, long story short, that's what we're supposed to find in order to jumpity jump, jump, jump to the right position. So, kiddos, all that's left is for us to do what? Solve. What's the NCR formula that we're supposed to be using for this 10 choose 2 or 10 C2? How do we do that? Good. So you agree with what I just wrote? Okay. Times x to the 8th, no big dealio. What do we do with this whole negative 2y squared thingamabob?
We could take the 2.
You can think about the squared goes to both the coefficient and the variable. So aren't you going to have negative 2 squared and y squared? Does that make sense? Because it's negative 2y times negative 2y. So we have negative 2 squared will just be 4. So we have 4 times x to the 8th y squared. But we still have this whole shabam to work out, right? If we were to do it by hand, just because we have practiced factorials, couldn't we do 10 times 9 times 8 factorial? You guys finish it off.
So 90 divided by 2, 45.
Because 8 factorial is reduced, and some of you guys were talking about the 2, and you could do 90 divided by 2, or you could reduce that, the 2 and the 10 to be 1 and 5. 5 times 9 is 45. 45 times 4? 180. X to the 8th y squared. So that means that for the 10th expansion, let's see if I at least got that one right. In the 10th expansion, the third coefficient should have been 45. Hey, yeah, 9 plus 36 from above, which was 1 and 8 and 8 and 28. Cool.
Good job.
Thanks, I got 1/5 the way right. Okay, so anyway. Can I give you guys one more?
Yeah, one.
Okay, let's try one more. You ready? What if I was to ask you, because then it's homework and then it's like, hey, probability, here we go. And we're about to get there. We're gonna get there today, hopefully. Although we did do a lot of life challenges, but some of us weren't ready for today, frankly, from section 9.6. What if I was to say the following? Find the x to the fourth term for x squared plus 3 to the power of 5.
This was not fun.
Yep. Sean knows why I'm giving you this one. Sean, while they're looking at it, can you just tell them why it's tricky?
It's because you have to make sure that you're matching up, and then you have to use your exponential multiplication rule. So when trying to choose what number you want to go to, remember that you're going to have to be multiplying both of your exponents at the same time.
Tricky.
Okay, so hold on. We have spots to fill, right? Does anybody know anything that we can fill in?
I think R is 5.
N is 5.
No, N is 15.
No.
Is it 2? N is
Don't
5
you-
over 5.
You see, can you take it out of the parentheses? You'd have a 10, an x to the 10th, and then a 3 to the 5th.
No, 3 isn't to the 5th though. Remember, we need this one. Why does 5 need to go here? I heard like half of you guys say that.
Because that's the exponent.
That's the n spot, right? Doesn't n equal 5 because we're raising it to the 5th power?
So 3.
What does the x to the 4th tell us?
That means that R is 1.
No, r's not 1.
No.
Why is my arrow pointing to the one we should fill in next? Isn't that the x? To make it x to the power of 4, what do we need in here? And Brandon, you said it. Why do we need a 2 there? Power to a power you multiply. So if the 2 is there, then hold on, what's going to go, what else can we fill in? What's going to go here? Because 2 plus 3 equals 5. Remember they have to add to be each other? So then, what am I going to fill into this box based on what I just filled in? A 3. Except I can't write.
I was like, what was that?
I have no idea. You guys see what I did? Then we're able to do our little formula with 5c3. Then we're going to have x to the 4th, and then we're going to have 27, and we have to put it all together. Five C3 would be 5 factorial, all over 5 minus 3, 2 factorial, 3 factorial, x to the 4th times 27. 5 times 4, don't worry, we got this. 2 times 1 times 3 factorial, that's going to cancel, that's going to cancel, that's a 1, that's a 2. 10 and 27 is 270, x to the 4th.
Did you get the 2 on the bottom?
Oh, 2 times 1. Kiddos, take these notes. Please get caught up for tomorrow. And if you guys want to be amazing, can you guys in your notes tonight get me the first page of 9.6? Sound good? All right, catch up on 9.5. Get me the first page of 9.6. We can bust it out tomorrow. But I tried to give as much grace as I can. I just can't give much more this week, all right? Catch up tonight.
My composition book ran out of pages, but it already has like some of chapter 9 in it.
Oh, just start a new one, but you can do like a little, like if you get a thin one. And if I were you, do a new table of contents, but then you just turn both of them in the next test.
Okay.
Because we still have like 2 more chapters, so you may as well. Thanks, Alyssa.
He was a carrot.